Buenos días. Bueno, gracias por venir aquí. Es un placer presentar a dos amigos. Son Nripal Adhikary Pranathi, respectivamente de Nepal y de India. Los dos trabajan en Nepal. Digamos, conforman una asociación, también una fundación, digamos, un despacho que se llama ABARI, es un despacho de arquitectura que trata otros temas desde el punto de vista social, pues agrícola. Vais a ver un poco el conjunto de sus trabajos, que me parecen un ejemplo extraordinario para ver cómo puedo mirar hacia atrás, mirar hacia la cultura, al contexto donde vivo, para proyectar una arquitectura contemporánea más sostenible, más integrada, más amable, más compatible con todo su entorno. Y llamaríamos también, pues eso, sostenibilidad desde todos los puntos de vista. Bien, ellos van a hablar en inglés, espero, no en nepalí, ¿no? Y ya veis que entienden un poquito de español. Bueno, the stage is yours. Thank you for coming.
Thank you, Camilla and Fernando and UPB for such a warm welcome. We feel really at home for the past almost 2 weeks that we've been here, and we've learned a lot, so it's a pleasure to be here and share our work with you. Originally, we were supposed to do 2, but we clubbed it because vernacular architecture and social innovation go hand in hand for us, so we are presenting together. We come from Nepal, and Nepal there's so much biodiversity, so we're very lucky that we have a lot of materials to work with. And geologically also, it's in an interesting position where we have so many biologically rich zones from the Himalayas all the way to the flat plains touching India. And originally our work was revolving around researching vernacular architecture across the cross-sections of the country, from rammed earth and stonework up in the hills to thatch and wattle and daub and adobe coming all the way to the plains. So over the years, the research has been the basis of all of our work, and we're also really attracted to the aesthetic aspect of it, which is really rich in Nepal and India, which we will go through in going forward in the presentation. This is a beautiful stone building from the mountains. It's a typical typology from the mountain region. And as we studied these projects, we were really interested to use it in a modern context. So as architects and designers, we wanted to use the language of the vernacular, but present it in a modern context to have relevant projects, contemporary projects. So at ABARI, we use the research to apply it onto our projects, and we'll show you in the future slides. And we love using bamboo because we have so many species of bamboo growing in Nepal, and it's one of the fastest growing materials, and it's at par with steel. So not only is it a great material structurally, but also aesthetically. And over the years, we've developed techniques to use it in our buildings in different ways. This was one of the projects. As you can see, the location it's quite remote, so we have a lot of natural materials, but we're also forced to use whatever is available around us because there's not too many roads. This was the school that we built in this beautiful hill region using stone. So with all the studies, we saw random rubble masonry and some dressed masonry, but this was like, we had the luck to work with local craftsmen and artisans who dress stone so well, it almost looks like a brick. And we had used this bamboo roof here, and this was at the epicenter of the earthquake that happened. And this building was, it was considered safe, and so the whole community used this space to occupy it during, the reconstruction phase because it was marked as safe. And this was actually the turning point of our practice because one of our projects was demonstrated as earthquake resistant using vernacular and local materials. And it really spearheaded the future projects. And maybe you want to say something here?
Yeah, I mean, this was We worked with very limited resources. We were upcycling anything, you know, like we found beer bottle. As Pranathi showed, this place has no road access. Actually, literally, if you had to get nuts and bolt, you'll have to walk 3 hours to get it. So it's really not only it forced us to be innovative in like using whatever we had. So as this was right at the epicenter, and we didn't know, of course, because we just finished this building. We just finished, and we were like kind of tired. You know, it was a lot of work to be there, and so we had almost no budget. So we built this it took us 3 years because of lack of budget, so logistics, and we used the, you know, like the drain pipes they had there, the beer bottles from a local bar, the stones and earth plaster. We didn't even have money to finish the flooring or put the furniture. And we just finished the project, and we was kind of tired, like I don't know, like whether we can continue like this, and you know, in so far region. And then interestingly, the earthquake happened, and this happened to be at the epicenter. So it was, you know, overnight it made us famous. Yeah.
Sorry, I moved the slide fast, but you know, you could see the contrast that this was in the neighborhood, in the town, the closest town, that, you know, concrete buildings were falling down, and this was the reason that, you know, we were able to have the attention, and we used that to raise awareness about how vernacular architecture is really important in the reconstruction process going forward. And we were able to present our work in policymakers' rooms and talk about, you know, how it's important to rebuild with natural materials. And so the next year or so we spent, you know, creating this open source design, especially for public buildings. And this one was approved, which was a school design using natural materials like rammed earth and compressed earth brick for walls and bamboo for the roof, similar to the school that, you know, withstood the earthquake. And this was a big win for us because not only did we get attention from the government, but also the local people were involved, and this is how, you know, the communities got involved. We had local women come and participate in the, you know, also the design, making of the design, you know, how we use the volume and how we use open spaces for teaching, and the building process itself. We had some, you know, workshops where we had women attend and make these compressed earth bricks. This is more about the typology of the building.
Yeah, we didn't really want to change the design, you know, because, you know, as anywhere, the governments, they tend to be conservative in like their design. So we were saying, okay, you can do, you know, this, mind you, this was an open source. So it was, we had put all the prints, all the details, everything on our website, and then we put it out there. So the only things we changed were how the walls were built using local material. We changed the ventilation so the air can go out, you know, like, so it becomes thermally comfortable. And we use natural paint on the walls. Yeah, so some like very minor tweaks that made the building be more inspiring and more livable. Because traditionally in schools, the government schools are made with concrete blocks, which is like, you know, only about 15 centimeter. And then sometimes they are left bare because they don't have the money to do it. And then they put a metal sheet on the roof and gets super hot or super cold, and you know, it kind of defeats the purpose of a building, because whenever it's hot you have to go out. If it's too cold you have to go out in the sun to get heat. So we said, okay, take your design but make it with earth, you know. That was our idea. And we added a few things, you know. We added the play space in between, yeah, and we made the building modular, you know, like in earthquake if it's, they say the safest building is a round building because it has got no corners. And then it's a square and then a rectangular. But if you want to make like, say, L-shaped or other forms, then it becomes very tricky. Then you need more reinforcement. So what we did is we made like modular buildings, so you can, you know, put it according to your contour. You know, mind you, we are in a very mountain region, so yeah, so we put it differently. Here's, using that typology, here's a school, the first school we did. As you can see, it is in the mountains. You don't see any roads here. You know, it's almost impossible in terms of conventional building. So you see,
Sorry.
You see these are the buildings is right in the cliff. You know, it's really challenging. And so we built this building, you know, like we had this compressed earth block, bamboo. And then we have to, you know, kind of advertise the beams because people thought mentally, psychologically more safe when you have these bands, right? So these are not necessary, but, you know, like people feel comfortable. And there's the play space in between, you know, like this is the inside, and the biggest comment we get whenever people come in, oh, it's so warm in here. The temperature is so different. You know, the thermal change is very visible, and it's. So we did that. We did the furniture with bamboo. You know, everything's like, you know, 100% there.
I think this was the success of the, you know, even before we made the building, where we had a lot of women and children partake in the workshops, and we changed the design of the earth press itself so that, you know, women could use it to make the bricks. And so it was a successful demonstration, not just to build the schools, but we also had it replicated in some farmers used the technology to build their houses as well.
Yeah, it was, and if you look at the budget, the 54% more or less goes to the material, and you know that, and about 35% on the labor. So about 11% goes to steel and concrete. So basically, 89% of the budget goes to the local community. And many times people ask me, what is the budget of the building? And what is the cost? And I say, whatever the cost is, it's a good cost because it's staying in the community.
So this is an example we really love showing because this is in Bhutan, and this is traditionally how they do the rammed earth there. And as we were studying the typologies of buildings, we were also looking at the construction methodology. And the formwork was something that we studied in depth because traditional buildings had you know, thicker walls, and this formwork was only allowing them to do a few meters a day. So what we developed over time was how to do it faster, but we wanted to keep the beauty of this, you know, the way they ram. So we took it and we applied it a little bit differently, which we'll show you. So we made a formwork which can be taken apart in parts, but at the same time it can build a whole wall in the same day. And you know, we used some steel parts, so it's easy to assemble and disassemble. And it was very important for us that the formwork fit in the small truck, because that's the only way we can move things in the hills. And this, go ahead.
This is the inside of the rammed earth. Like, you know, mind you, we are in a very high seismic zone. So one of the innovation Pranathi was saying was making the rammed earth wall traditionally about like 60, 70 centimeters, go back to 40 centimeters, and make it multi-story. And also, traditionally what they did is they had the formworks very small. So that meant you can only do sections, and then somehow you have to plaster it. So we wanted to avoid that. And then, so we put this mesh and then a reinforcement on it. Actually, we've just done a sample of this at the UPV, at the lab. So if you want to see how the connections are in person, you can go visit it there.
And we also have, every time we travel in Nepal, we try to collect clay from everywhere we visit. So this was something that we developed over time as well, to use different forms of clay in the interiors of the wall as a finish. And the formwork also allowed for us to play with different shapes and creating patterns, because it allows for the interior of the wall to be created in one go.
And you can see there's this formwork here. So it also acts as a scaffolding. And one major innovation, as we said, is you can build like one huge section in one go, right? And then you can create this beautiful murals and stuff as you build. It's a really nice Zen process of building. It's like building an art as you do. Go. So, after the earthquake, with all this innovation, before the earthquake, we were building in the most remote areas of Nepal, as I showed you earlier, where there are no roads, because people in the city were not interested. They thought it was, it was only for rural areas. And after the earthquake, we got a commission to do one of the largest archives of books in Nepal. So this is right in the city. Yeah, so it was a big vindication. Like now we're building with earth and bamboo right in the center of the city. So it was a big deal for us. So here's the interior. Like here, what we wanted to advertise, not, bamboo is considered as poor man's material. People, if they do it, there are some modern people who want to use bamboo, but they want to hide it and cement plaster it so it looks like modern material. But we're like, no, it's such a great material, you have to advertise it. It's, so we built, so we expose this. This library is built in such a way that the books are not, you're not allowed to access these books because these are rare books. So you go to the top and look top of the office, and then look at these books, and then and you can see the structures within it. So it kind of creates that gaze and creating these lights. So so it's kind of highlighting all the bamboo stuff. And what's really interesting also, we found architecturally, the material we use is earth, and it breathes. Like with these archives, traditionally they put air conditioning, which is very bad for the books because it makes it dry. But with the breathing of the air, the books were really nice. So this was something we learned from the curator, the archivist of the place. And here, like we are showing, different traditional aspect, but kind of like a little bit modifying it, adding the big windows. And we know the limitation of the material, and we know so what it's good at. We're not like bamboo fanatic where we just go like bamboo, bamboo, bamboo everywhere. So we know like where we can use it the best, like judicial use of the material. For example, we know like if you do earth plaster, mind you, when we do rammed earth, we don't use any cement, right? We don't stabilize it. So that means it has to be put above ground, so there's a big, nice moisture barrier. And then we put natural paint, and we use milk protein, casein, for the waterproofing. But still, we put a nice overhang on the top, so it doesn't get direct rain and gets washed off.
It was also about developing a new typology, because rammed earth traditionally is used where it doesn't rain so much. So we had to come up with this innovative way of having multiple overhangs or bigger overhangs to protect the walls. And whenever we went really high, we used a combination of rammed earth and compressed earth brick, or in this case, it's wattle and daub.
Yeah, and also one interesting thing we did is, yes, as she said, this is wattle and daub. This is a very thin wall. And the walls are independent of the roof, right? So if there's an earthquake, this is how traditionally it was done. If there's an earthquake, if there's any movement, the walls can fall. We allow for that fall, but the roof is still standing, There are stories in the mountains where people are like, they are sleeping and the wall falls, and they're like, okay, tomorrow we'll fix it. They don't have to worry so much about it because the roof is safe. And here are the different angles with the natural paint. It's a nice space to come and read. And here's the exterior. With these perforated windows, terracotta roof, big struts, long open windows, So it's been there almost 10 years and it looks still as new. So it was a big vindication, It's like, yeah, you can build a public building right in the center of Kathmandu and it can last for a long time, right? So after this, we were like, yeah, give us more projects, and we are more excited. Next, here's the cross section. Here's the bamboo. It's kind of, as she described, it's such a lightweight material. It's almost like, people compare it to steel. It's definitely stronger than steel, but steel is strong, but it's heavy. But bamboo is strong. It's lightweight. It's more like carbon fibers, if you want to compare it to modern industrial material. So it's lightweight and strong. So, I don't know if you know this, but Wright brothers, when they first built their prototype airplane, they used bamboo because it's lightweight. Yeah. Yeah. And so here's the cross section to show that it's separate from the walls. Next. And so our interest is also in designing public spaces, because we feel it has more need in the country, because we need, with bamboo you can achieve that, you can create a larger span and use local resources, and it's cheaper. So another project we did was a school. This is also in a remote area, an area that is developing, right? It's a growing city. So the idea is to use the resources and to come up with a typology which can be replicated. Mm-hmm.
Yeah, here it was important for us that, it was part of this early childhood village. It was part of the preschool, and the younger generation of the school was using this space. So here it was important that we have these elements which are rammed earth, but also these semi-open spaces in between where the children can play and use the space differently. And here we used shingles, like bamboo shingles on the in the exterior.
And rammed earth, like if you see, there's a whole gradation of colors from red to yellow. So we wanted to kind of like catalog and celebrate the different soil types that was around the village, you know. It's really sometimes so sad to see, you drive, and then there's a beautiful red clay and yellow clay, and then people are just, you know, it's like nice mountains, and they bring a bulldozer and then build a concrete building, and I'm like, what are you doing? You know, so but we like take that and kind of celebrate that. Yeah, that was the idea. And as Pranathi was showing, we have, it's a big public space. So there's a classroom here, which has got the thermal mass. And then we have the in-between space, which we call the play space, right? This school was very inspired by Steiner School, Waldorf School. So it's, you know, like closed area and open area. So the kids can be inside when they want, when it's cold, and then also outside. And, you know, like every classroom has these kind of play space. And we're working in a very limited area. So, and we try to, it's passive solar design, which is most of our buildings. So we opened it, so, you know, you get the biggest sun exposure from here, you know, in the south. So you get this sun exposure, and it warms the classrooms, and also it allows the space to be outside. And then we make the pathways with sand and like vegetable plants, so kids can run around this. You know, we try to save all the trees. You know, like this is a big mango tree, so we build this balcony right next to the mango, so kids can go out and just pluck the mango and eat.
Yeah, it was important for us to have this green element because we are set amidst a farming community, and we wanted to incorporate those you know, things into the building as well. And we had some also workshop with the children and some of the teachers to come up with the designs for some of the, you know, like the birds on the walls and everything.
And also the truss kind of doubles as a
jungle gym sort of a thing, like kids love hanging from here.
Yeah. So yeah, it's a truss and a jungle gym combined. Yeah, we encourage the kids to be on top, and so when the teachers are in the classroom, the kids are on the top. And here's a different weaving, you know, as bamboo can also be, it's such an interesting material because when it's young, you can eat it, right? It's when it's up to 3 months, it's very soft and succulent. You can eat bamboo shoot. And if you don't eat that, you let it grow, it becomes a plant. And then for 2 years, it's kind of soft. You can cut it and then use it in fibers. You know, like now there's a lot of bamboo fibers, right? The fabric. So you can use it in textile. And they say if you don't use it even after 3 years, then it becomes strong and like very hardy. Then you can use it for construction. Yeah? And usually the bottom part is very strong. You can use it for columns and beams. And the top part is hollow and very light. So you can cut that and open it and then create really interesting weaving patterns, right? You can open, it's really nice, flexible material. And here's the classroom inside, you know, again, like with, we have not been shy to use some steel beams because we're trying to get a big span. And mind you, this is a public building in a very earthquake zone area. So we're like, you know, we want to show, because there are a lot of curious people, like, you know, like the government officials who want to come and be like, is this strong? And then they see all this, how we've kind of used two different materials, you know, modern in conjunction with the traditional. they feel safe, yeah. And then also they go like, oh wow, this is cool. I like the texture, and then they see. It's a nice way to convince people at this point.
We've also used the bamboo, the flattened bamboo in the ceiling as well as some of the openings. And this entire connecting path is using this flattened bamboo, so it's very lightweight, it's very airy, and this area gets a lot of heat. The summers are very hot here, so it's also a solar passive cooling system where the shutters open and you let in the wind. A lot of times they use the outdoor area as classrooms rather than the indoor area because it's very nice breeze coming in. And this is, they also have dedicated outdoor classrooms because it's Steiner education. So, we have these barricaded spaces for the children to play and, do their classrooms outside. And again, it's inviting the green spaces inside. We had a lot of leftover bamboo and other materials which we used to create some benches and some playthings for the children.
And even this sink you see, it's bamboo, right? It's so such a versatile material. And here's the big open area, where they do the performance, and then that part we've left open. It's pretty big. It's 8 meters wide and 30 meters long, So the top part is lightweight and the bottom part is rammed earth. So it creates a nice structural and visual balance.
This is a small house project. It's our house in the city, and this was our COVID project, or rather just before COVID. So we really wanted to continue our work even though we didn't have any other projects going on during those 2 years. So we built a small house in the center of the city using rammed earth. And it's also designed using solar passive design principles. And the 2-story rammed earth structure is where the rooms are, and the other spaces capture the sunlight and transfer the heat into the house for other functions.
Yeah, and also a lot of people say like, can you build rammed earth in the city? Because in the city, of course, Kathmandu has a population of almost 5 million people. So the real estate is very expensive and limited, and people want to build as small a wall as possible so they can get more space. And they think like with earth you cannot do it, but we're like, yes, you can do it. You can even have a garden. You can have a space that's warm. So as she said, like we wanted to do passive solar. So if you notice, like with rammed earth, as I said, you cannot make very complex structure at once, but you have to be creative. If you want to do, you have to do it modular, right? So you want to do one structure here, then another structure here, and bamboo kind of works as a bridge to structurally connect them. So if there's an earthquake, the bamboo works like an accordion, it kind of moves back and forth, but while the rammed earth stays rigid. So here, this part is rigid earth, like it's absorbing the thermal mass, and there's another rammed earth here, and in between we have bamboo and glass. It's really like we first innovate, use it ourselves, and then go out in the market. For example, here's a bamboo that's connected to glass, right?
And another innovation we tried here was, hiding the beams, in the intermediate beams within the rammed earth. So we wanted to try this so we can use it for other public buildings where you wouldn't want to show certain concrete elements, and it looks very, homogeneous and like a monolithic wall. So the beam is actually hidden here in this level.
Yeah. And also here, like we're getting a bit comfortable with exposing rammed earth to the weather element. Here it's again coated with casein. It's such a amazing material. It's this milk protein with some borax. It creates this very nice permeable surface that makes the structure waterproof.
And the roof here was where we really tried to have the elements of a truss, working with this bamboo roof, and we wanted to open it to a skylight. And this was a really interesting and a very quick build, because we prefabricated it, and because of COVID, we had to think differently. So we designed it and made it in a place and brought it and, built it so quickly. So this was also an interesting exercise because we were able to incorporate it into our other projects as well.
And also you're sleeping here and you're looking up, it's like a mandala, right? So you have these triangles that is holding another set of triangles, and then in the center there's this the skylight. So when you're sleeping, you're looking at this really interesting mandala. Here's the mandala with nice earth plaster, and then we exposed a layer of bamboo and then another layer of earth again. So it creates this very interesting visual vocabulary. Here's how rammed earth connects to the bamboo, So trying to show that it is a contemporary material, in Nepal, because it is traditionally used all the time. Like even now, you look at the census, 75% of the construction is earth-based, but modern construction, let's say 99%, is using steel and concrete. So we're saying no, you can do contemporary structures. So here's another major innovation came.
We had another turning point, like COVID was one of them, and then we had this collaboration with Camilla and Fernando helping us with learning about Bovedas, with Salvador, who came to visit us, and we did this workshop. And this was a turning point because the way we saw roofs totally changed after this, and we were able to use a local material, which is this brick made very close to where we live, and so we've been having so much fun with it.
And these tiles were only put on the floor as floor tiles. And then we were like, okay, we use this on the roof, right? So here's the process, using these small 15 by 15 tiles and then putting it on the roof. So it was just a small change in the form, but the materials were available there, and it was so exciting. So once we did this, we did one structure, and then we did a couple of structures like this, right? We did one 4 meters, one another 4 meters, one. We don't have the photo of that. But then I was like, because remember we're doing a lot of school projects, and we want to do. There was another project where we had to do about 200 square meters of cafeteria. So we're like, okay, we're not so comfortable with 200 meters yet, with one single boveda, with tile vaulting. Let's do bamboo, and also there are a lot of little kids, so we didn't want the liability at this point. So we used the same typology, and then we went with bamboo. Next, you see, as I was describing, bamboo is a hollow surface, right? And the strength comes longitudinally with its tube, and then you can cut this tube into small strips. Very easy. You just take a knife and do it, and then become super flexible. This is one piece. Just you bend it like this without any need of heat, and then you laminate multiple. So we get this desired shape we want. And you know, where there's a lot of thirst, we have a concrete beam. And then we started doing this, so we prefabricate these elements and then we add, you know. So the generating form was a bit tricky, but you know, once you do it, you just have to make a jig. You put the thing there, just carry it and put it on top. So here's how we do it. You know, it's modular. We just keep increasing it. Here's you know, it's a construction photo. After we do this, we add a layer of bamboo on this, right? It's a pretty big space. You know, this is like a cantina for kids. So we wanted kind of like very playful area. You know, just you can walk around and you know. And here's a small video. Like once you put the layer of bamboo, then you plaster it. It's very simple, you know, like, if you think about it, it's just like literally, we say it's earth and grass, literally, you know, it's only earth and grass and you're building these structures. You don't really need much. So here and after this, we, put some earthen paint. These are red clay, yellow clay. So another example, and we are like, everybody came here, it's, and they're like, we want to, so here's the thing. Here we had a secondary roof because, you know, these are dome after domes after domes, so it's creating these valleys. So in order to avoid that, for water to come in, we added a big roof on top of this. Here's, this roof, like a pitch roof. On top of this, and here's the one module, right? This is repeating, and here you can see all these ribs. And these ribs are what makes it rigid and earthquake resistant. So our next dream is to have these ribs and then have smaller prefabricated earthen panels, earthen bricks that stays on this. So it creates even more thermal mass. So here's another project which we want to end with. So here's it's a monastery again, and this is where it is. Like you look at the road, it's crazy. So this is like half of, I would say more than half of Nepal. Like 90%, 70% of Nepal is all mountains, right? So the road situation is very tricky. There's a rain and then the road doesn't work. So we need a 4-wheel truck. It's a nightmare to build this. But there we wanted to build a monastery because there are like so many nuns and like little monks there. So we wanted to create a space. And we said, okay, we'll use whatever is there, right? So here's the main monastery, which I'll talk about in a bit. And this is the nunnery where the stay, the kids. And here's, and then this is the eating area, right? And we used these made with like just clay and bamboo. Here's the section. So we don't want to change the landscape. So we just work with however it is. See, all these are contours, very steep contours. So we just kind of carve out a little bit and just build the structures here. Here is the canteen that I was talking about. So the earlier one was a 4-meter module, and this time we said, why not? Like, let's go bigger. Let's do a 17-meter module. So we prefabricated them, and so here you see this 2-person goes to the top. You don't really need much tools, right? and then you prefabricate them in a studio, and then we just bring them and just put them. So one panel is not more than 5 kilos, but it's huge, right? So here's the interior with this bracing. Then we did a secondary layer of waterproofing. This time we didn't have secondary roof. In the inside is earth, and the outside is a layer of waterproofing concrete. Here we've used concrete. But I also kind of demonstrate the concrete, that it can really take the load, right? So we have this kind of Gothic looking arch, this like round arches with waffles, and earth paint. And there's huge glass windows to the side, this concrete pedestal, and here the happy monks doing their daily walking. So it's so many people come here to visit, to get inspired, to meditate. And it's got one thing we found is, by default, these materials have such a spiritual quality that it's a really nice area to meditate. Here's some of the details, really the ribs are not more than 3 centimeters, right? But super strong. And here's the inside. Here's the living area. This is built with compressed earth block with different clay, and then this is wattle and daub. And we were like, we love this the Boveda tabiaka, the flat shell, and we want to do that, but let's do a bamboo version of this. So I'll show you in the next one. We have the roof is like this. It's like kind of woven. So it's literally, you just weave the bamboo to the shape, and it's super strong. Like 20 people jump on it and nothing happens, right? And remember, these are kids running around like crazy, but there's no flex. It's kind of nice. It's got the very interesting, and then we put the gypsum on top, not on the bottom, top, just for the protection from cavity. And this is the interior of the big monastery, where we have these columns, inclined columns. These are with steel. It also works, kind of like an arch. All the pressure is going downwards, right? Here, and when you look up, you have this beautiful mandala. It's got this triangles and squares and triangles, and the lights are coming through. So this is what you see when you look on the top. And this is from the side. It's very zen. We didn't want many colors, with just the earth plaster. And here people are meditating with natural wood finish, and also not polished, because it takes out the smell. And with earth and bamboo, it's got a very nice smell. It literally is breathing, kind of symbolic of these people who are meditating inside. Here's the outside. This is rammed earth with bamboo frame, and then the wattle and daub, lightweight. So this is 15 meters, So we kind of showed you the evolution of our work, from this humble school to this 15 meters, over the course of 12, 13 years. And also it's a very interesting vindication of the material, because monasteries are supposed to last, like here in Spain, last hundreds of years. So somebody's come to us and says, okay, we trust your material and we want to build something that lasts forever. So we are very excited. So we've been doing this. So thank you.
Bueno, muchas gracias. La verdad es que no solo es bonito aquí, o sea, cuando uno lo ve allí es todavía más bonito. Es decir, que al final hemos tenido la suerte de visitar algunos de estos edificios, o casi todos, y son una preciosidad. No solo es la imagen, es un poco ese sentimiento un poco inefable. Abro el turno para ver si tenéis alguna pregunta.
Hi, my question is more about regulations, and when it comes to convince government officials that are used to reinforced concrete in their buildings, and you come up and you're like, hi, I'm going to build with bamboo. How does it go with permits?
It's very difficult. It's not easy. But we kind of walk around sometimes, like we're doing another monastery which is under construction. It's a 3-story rammed earth structure. But there we had to use steel reinforcement because they would not approve without it. But we use rammed earth as walls, And for the bamboo structure, bamboo is considered as a temporary material, right? So you can build without needing the permit, really. So, but they're trying to change that, and we are trying to fight that too. But so far it's relatively easy, right? Not officially, but unofficially, it's easy because there's not a very strong regulation. But as we are building more, now it's becoming like there's a lot of visibility now. So more people are interested. They're coming and seeing. So we have to be careful. So we have to have some steel reinforcement, more than we actually need, because or else we will not get the approval. This is 15. We're doing another one which is 21. So slowly, let's see. One day we'll build a bamboo Eiffel Tower.
¿Más preguntas? Voy.
Hi. It's a pleasure for me to know you. I'm following your job, your work for many years. I'm a structural engineer from Colombia, of bamboo constructions. And I have 2 questions. The first is about what kind of species of bamboo do you use? It's important. In Colombia we have other kind of species. And the second question is what do you think about this? How could we take these materials to implement in urban context, for example, here in Europe? What do you think? It's a big question for all biobuilders in the world, because we know regulations is very important, the interest in the academic spaces of people, of course. But what do you think? Because I don't have question of this, I don't have answer of this question now.
Very nice to hear from you. I am very inspired by the works in Colombia. Architects like Simon Velez who've done amazing work. And I mean, he kind of showed that one person can really change their perception. In Colombia, they're building like very nice big structures with bamboo. And just through smaller innovations like connections, the major bamboo is not a homogeneous material like the industrial material. It's got variation, right? So if you say I want a bamboo of diameter 8, you may not get it. You may get some 8, some 7. So there is that variation. And so, yeah, so what if we want to convince the engineers, which is very difficult because you're working with heterogeneous material, right? You're not working, and many of the tests has to be non-destructive because every bamboo is different to the other one. Yeah. So, but there are many engineers also from Colombia, South America also. There's a lot of bamboo in the southern hemisphere. So there's a lot of tests happening. A lot of engineers are excited about this. So I'm hoping they will kind of do more testing and get the approval needed. And it is technically possible, in Hawaii, which lies in a very high seismic and high tornado area. And so they've met all the regulations to build a bamboo structure. It's very expensive because it has to come from South America. But they've done it. I don't know about Spain because I don't know, there's not much bamboo, but so many interested people are doing these research. So hopefully, with the new generations of interest, I think we can be able to build in urban areas, also in industrial areas. What is also very exciting is in the last World Expo, I think it was 2015, many industrial countries like Portugal, Germany, China, they built their pavilion with bamboo, right? And it's very symbolic because these same countries in the same World Expo about 100 years ago were built with steel because they thought the steel is the future. So these countries are now building with bamboo, this pavilion, the World Pavilion. So many countries are looking at it as a future material. So I think there will be more research to do that. And the last question is of the species. It's not guadua, but we have. When I was in Colombia, I smuggled a little bit of guadua, and then we are growing it, and it's doing really well. But we have another species. It's called Bambusa balcua, which I think is better than guadua. It's stronger than guadua because it's got no holes, and it's very strong. But it's not as straight as guadua. So I don't know if I answered your question because it's.
Yeah, I just wanted to add that to both your questions was that we need more collaboration in this sense because we are more builders and architects, and it would be nice for these buildings to be tested or studied. We are we have a free rein because we build and then of course we do structural tests, but not of the entire building. So maybe as engineers and people who do research in materials and material testing, it would be nice to collaborate or have these studies done. So we are happy to share what we know, and maybe this could help in creating a code or a case study for others who want to try the material.
I wanted to ask about the picture of the construction, which was a bedroom, like a mandala, you said. Like the joints here of the bamboo, for example, they were like very minimal, like we couldn't see them. So I wanted to know, I don't know, like if you use like some resin or what kind of materials work well to help the bamboo to become like stronger.
So we have two kinds of joint. One is a bracket joint. So we make like 5 millimeter steel, and then we make a certain bracket, right, according to the specific joint. So it changes. She's trying to show me. No, it's in the front. So you insert that. So there's a steel, a little bit of steel that connects it. So it gives that homogeneity. It's also, you can actually test it because The major failure happens at the joint, but at the joint we have a little bit of steel, so you can look at it, right? And so the connection is fish mouth. So, you know, like we have bamboo, we have another bamboo, and then a small steel joint, about 35 centimeters, that goes inside.
Yeah, this is called a fish mouth because, you know, it's a handmade joint. It's actually slower. So this was a more artisanal joint, but in more of our commercial buildings, we try to use the brackets like you see in this one. So we prefabricate the connection, and it's really easy to build. It's like Lego. Yeah.
Okay. Thank you.
Any other question? Okay.
Thank you. First of all, I just want to say thank you for showing all these things because they look absolutely impressive. It's and you know, it makes me think. Okay, in this case it's bamboo, but kind of timber works a similar way. And in Europe, we've mostly just lost the forests. And the question is not maybe why we don't build in bamboo, but why we lost the forests that would allow us. But anyway, that's a long discussion. My question is, you're showing sites that are quite remote and the projects take a while. So I'm just interested, do you move to the places where you build, or how do you manage the construction process?
So we are a design and build team, right? So it's not, because the industry isn't, because we are the first ones to actually do this, and we're doing a lot of innovation. So we have our own team. So we go to site, stay there, finish the project, and go to another site. So we cannot do many projects, you know, like at a time we do, you know, 2-3 projects at a time because of limited resources. And this is very artisanal work, right? So it's, we cannot do many projects at once.
So, thank you very much. This lecture will be edited and will be uploaded, so you can watch it again if you want. And they have told us during these 2 weeks that, ¿you mean in Spanish? ¿Español? Sí. Español. Nos han ofrecido, por si estáis interesados, que están abiertos a ir gente allí, si queréis colaborar con ellos, estar unos meses allí. Ellos ofrecen comida y alojamientos, tenéis que cogeros el billete, pero que están encantados de hacer intercambios. De hecho, hacen un montón de intercambios con muchas universidades y otra gente. O sea, que si queréis tener una experiencia, aprender esto y que luego que esa mancha de aceite siga en todas partes, esto es muy necesario. Están encantados de recibiros. O sea que, bueno, ahí tenéis el ofrecimiento. Thank you very much, and you're welcome for the next time here. Thank you.
Thank you.
Thank you so
again
much for the opportunity.
Here's our website.
If you want to connect with us, please write to us. And you're all welcome to Nepal. So please come and let's collaborate and make more bamboo buildings.